Hello. So this is the lesson we were going to do yesterday, and what we're going to do is we're going to find areas bounded by curves, the x-axis, and certain x values, the limits. So here we've got the curve y equals x squared plus x minus 12, and I want to find the shaded area so you can see clearly we are between 5 and 4. So we're going to integrate. Now, if the question literally said find, it would be absolutely fine for you to just put that in your calculator. And if you put it in your calculator, you're going to get the answer 77 over 66. Okay? If the question says find, perfect. However, if the question said determine or use detailed reasoning, it wants to see absolutely everything. So remember, detailed reasoning means act as though you don't have a calculator. So it would want to see your function integrated, and then it would like to see your values being substituted into the integral. Okay? It's not the point that maybe you could do it in your head, or you definitely know how to use your calculator to do it. By asking you for detailed reasoning, they want to see that you absolutely understand what it is going on here mathematically. Once you've done that, I would then put it in my calculator using my option calc and my integrals. So I think I might have my calculator. No, I can't get my calculator easily up. So do that at the end. So you would then, it doesn't need to see you working out individually. So that would be your answer there. Question 2. So I think, again, there are two ways you could do this. If the question said find, you would literally, you can see that your curve is 6 minus x squared, and you are integrating between 2 and negative 2. And again, if find, you would put that into your calculator straight away. 56 over 3. You can see I'm using my new laptop and it flips to make some kind of writing on thing. But if I touch my sleeve, it sort of rubs it out, so I need to be really careful. However, if it said show detailed reasoning, you could. I think there would be two ways that you could do this. You could integrate between 2 and negative 2. I don't know why I've done that. I've already written it. So you could integrate between 2 and negative 2. So you're going to get 6x minus a third x cubed. And you could substitute those in. And you've got a calculator, so it doesn't matter that you're using, sorry, I put the negative in too early, get rid of that. So 6 times 2 minus a third times 2 cubed. Take away your lower limit going in. Remember, you're taking away the whole of the thing. And then, obviously, write my answer down. I've put in my calculator. Or, okay, you could spot that this particular curve is symmetrical. So what you could do is you could find the area between 0 and 2. And, of course, 0 is a lovely value to substitute in as a limit. And then double it. Right, number 3. Again, really straightforward. You're finding the area bounded by the curve x cubed and the limits. Okay, can you see that there's a little error there, that doesn't make sense, between the limits 2 and negative 1. Now again, find, put that in your calculator. And what that's really testing you on is, do you know that the area bounded by a curve and the x-axis is integration? It just won't carry that many marks. That's fine. And again, what you could do if it says show detailed reasoning, I won't repeat it again. Detailed reasoning, you would integrate that and show the limits going in. It must see the limits being substituted. Right. Now we talked in the lesson about areas below the x-axis. So if we were looking for areas below the x-axis, okay, can you see that's not really working? It's just too below the x-axis. This is my first time using this, so you're going to have to bear with me. Right, for below the x-axis. Now we know that if your area is below the x-axis, the area, or the answer to our integral, will be negative. It's like a directed area. So the negative integral means your area is below the x-axis. But areas are always positive. So you take your negative solution and you make it positive. Okay. Right, so this first one here. And this is slightly different because it hasn't given you the limits. So the first thing I'm going to do is I want to find where this curve crosses the x-axis. And obviously it crosses the x-axis when y is 0. If it says find, just put it in your calculator. If not, show how you're getting it. So you're getting -5. You're not getting -5, you're getting +5 and -1. So 5 and -1. Okay, so what I'm going to do is I'm going to integrate x squared minus 4x minus 5 between 5 and -1. Now, I can put that in my calculator. And if it says find, and that would be perfect. And that would give me -36. So my area is the absolute value of -36. So my area is 36. And that would be the answer to a find question. Detailed reasoning, you show the integration, you show the limits going in, and then you might even explain why your negative solution becomes positive. Right, slightly harder. So what we've got here, so this is question 5, we've got a curve that has a little bit above the x-axis and a little bit below the x-axis. What we can't do is integrate between 3 and 1. Because what's going to happen is the area between 3 and 2 is positive, but because the area between 2 and 1 is negative, then it's going to eat away at it and take this area away from that area. So if you did put it in your calculator, so I'm going to do that now. So if I put in x squared minus 3x plus 2, and between my limits 3 and 1, that integral gives me 2/3. Now that I know is not the area. What I'm going to do is I'm going to integrate between 3 and 2. And that's going to find, so really what I'm going to do, it's almost like a compound area question. I'm going to find area 1 and area 2. So area 1 would be between the x values 3 and 2. So if I'm just going to delete that. And that gives me 5/6. So that's for area 1. Area 2, now I'm going to integrate between 2 and 1. But I know that if I integrate between 2 and 1, it's below the x-axis and it's going to give me my negative area. So the total area is 5/6 plus this area. The total area is 1. Right. Let's try another one. So question 6. So here we've got the curve y equals 4x squared. And you can see we've got a positive area and a negative area. And we want the total area. Right. Before I go any further, I need to find that x value, and that's when y equals 0. So I know I've got 2 plus x, 2 minus x. It's a difference of 2 squares. So I'm going to have -2, and I'm going to have 2. Obviously, that's -2. That's not being used. So it's 2. So I'm going to integrate between 2 and, of course, 0. And that's going to give me area 1. Now, obviously, if it said detailed reasoning, I would be showing a full method. So that's 16/3. And number 2, I'm now going to find this separate area here between 3 and 2. Now, because it's below the x-axis, I'm expecting it to be negative. So if I just put that into my calculator, again, I'm treating it like a find because I feel I'm just repeating myself if I keep saying, you know, what you would do for detailed reasoning, -7/3. So my total area is 16/3 plus 7/3, so 23/3. And I was going to just do one last one. So again, I need to find where I cross there. So x squared minus 3x minus 10. And again, if it's a find question, you could just shove that into your calculator. Sorry, I'm struggling a bit with that x. Okay. X minus 5, x plus 2. So you've got your, hang on. That didn't work, did it? Okay, so I think I need to change that limit. I don't think that's a correct limit. Let's change that to 7. So I think it crosses the x-axis at 5. So I'm going to, again, I've got area 1 and area 2. Area 1 is between 7 and 5, and we've got x squared minus 3x minus 10. So I'm just going to put that in my calculator. I'm acting as though it's just a find question, minus 3x minus 10. Scroll up for 7 and scroll down for 5. So I've got 50/3. And area 2, if I integrate between 5 and 1, and so just scroll up and change those limits. Again, this is for find, not for detailed reasoning. So 5 and 1, I've got minus 104/3. So my total area is 50 plus 104/3. So 154/3. Okay, hopefully that makes total sense. Thank you.